Hey there, in this lab we're looking at thin layer chromatography, which is a process by which you can separate the component parts of a mixture. Since we've been talking about the classification of matter and different types of substances and mixtures, decided that we'll look at thin layer chromatography as a way to separate certain types of mixtures. In this particular lab, we're going to have two mixtures. One mixture is going to be the ink from a black Sharpie pen. One mixture is going to be the ink from a black Sharpie pen. The other mixture is going to be the ink from a red Sharpie pen. These are mixtures, and if there's a way we can separate out the component parts of the mixture that is the ink, we might be able to see those component parts and maybe better classify the particular type of matter that makes up our ink. In order to do that, we're going to have a piece of absorbent material, which in this case is just this coffee filter. We're going to draw a couple dots of ink of each color on two strips of coffee filter paper that'll come out, each strip about 2 centimeters in width. We're going to hang those strips of paper into this beaker, and at the bottom of the beaker we're just going to put a very small amount of our solvent, which will be our isopropyl alcohol, which is a compound that you can see diagrammed here. Having our strips held down into or hanging down into the beaker, the isopropyl alcohol at the bottom is going to rise up through a process called capillary action through our coffee filter paper, and it's going to drag the pieces or parts of our mixtures with it. And we should see something interesting. We might see different colors, we might see different types or widths of streaks of ink as it separates. The process of thin layer chromatography will let us see a little bit of what the component parts of our mixture are. We have a couple other materials that we're going to need to use. Besides our coffee paper filter, our mixtures of ink, besides our beaker and our solvent, the isopropyl alcohol, we'll also use a ruler to kind of control the width of our slices of filter paper. We'll need scissors for that. We'll also be taking a couple of paper clips here, which you'll see how those are being used. Those paper clips will be folded out into a more or less straight line of paper clip, and that will hold our filter paper above our solvent so that the filter paper hangs from the paper clip and goes down and just barely touches the surface of that isopropyl alcohol solvent at the bottom. We'll also have a stopwatch running, and we'll probably just put a digital one on the screen. Once we start our experiment, we'll take note of times at which we notice certain things happening, which you'll diagram and describe in your lab guide. What you're turning in for this lab is just the completed lab guide. Let's take a look at it for a moment here. Make sure you read through the top description of what's happening in thin layer chromatography. In our particular lab, our absorbent material where we're going to place our mixtures is the coffee filter paper. We'll just draw a couple dots of each ink. The mixture that we want to separate is going to be the marker ink, so we'll have two of those, the black Sharpie and the red Sharpie. The solvent, which is going to do the separating of our mixture, is the isopropyl alcohol that we mentioned before. Make sure you answer the pre-lab questions. If you need to look some of this up, go on ahead and do so. You might find it in the text, the presentations, or you can use the internet with reliable sources to answer those. The procedure is listed here in listed steps, primarily for people doing this in class, but make sure you read through that to understand what steps I'm actually going through. It'll complete the rest of the lab guide, starting with the objective, a main question, or the purpose. Think, what are we trying to do here with this thin layer chromatography? What's the isopropyl alcohol doing to our ink mixtures? And you can come back and change this if you want later. Diagram materials, I've shown you the materials, we'll see them more close up in a moment, but digitally input a diagram that you can use if you're using Cami to edit this PDF. Use some of the shape functions and some of the freehand pen drawing functions on there to give the best diagram that you can, and then also name the materials that are being used as well. Down here in our observations or data section, We're always going to include the time, because we're going to have a timer running as things are going on. Include the time, like how many minutes, seconds, and milliseconds have passed. And when you record that time, we'll then record some observations and a sort of drawn picture of what we see happening on the filter paper, as well as a few phrases that describe with our written words what we see happening. So to read together, include what time your experiment started and ended, and describe what you noticed about the two different types of ink when the solvent, that's our isopropyl alcohol, passed through them. Draw pictures to accompany your observations. Have a stopwatch running, which we'll see on the screen, so that you can take at least 5 time measurements and describe your observations. For example, after 1 minute has passed, what do you observe? Draw a little sketch of that. After 2 minutes have passed, what do you observe, etc. The observations and data should be well organized down here. So break them into parts. It could be like 6 squares if you break up the paper here to do 6 different observations. With each one, you should have a time stamp. For instance, at 5 minutes and 31 seconds, this is what our chromatography experiment was showing us. This is what our filter paper looked like with the ink on it. We'll have space for a conclusion, a summary of your investigation, describe your observations, whether you noticed anything unexpected, describe any inferences you can make, describe ways you could improve this experiment or change it. Would you look at different types of inks? Do you think Sharpie is going to be different from an Expo marker? Is that going to be different from a regular Crayola marker? There's a lot you can put in here about how you could try to take this experiment or investigation in a different direction, and then answer the reflection questions at the very end, and that'll be all. All right, and make sure you read the beginning and answer the pre-lab questions before we get going. All right, so we're going to set up our station here. This would be something that we're doing, looking at our procedure. This is how students in class will see the procedure and set up their stations with stuff. First, we're taking our coffee filter paper and cutting it into about 2 centimeter wide strips there that you can see in the middle. We're going to unbend our paper clips so that they can be used as a holder like you see up here to prevent our filter paper from falling down. Then we're going to hold our filter paper so that it's just barely touching the bottom and get rid of any of the excess paper on there. So we just have something like this set up, and then we're going to pour our solvent, the isopropyl alcohol, in the very bottom just a little bit so it's touching just the bottom of our both filter papers and it can start to travel upwards. We're going to have our mixtures, our inks. See these large dots will be at the bottom closer to the isopropyl alcohol. And then at the top, we're also going to kind of color code it because we want to remember which one is which. So that's why we're going to have those little dots at the top. And once we're ready to go, we'll have our timer going in the background. We'll just have a digital one going in the video. And of course, you can go back and to a previous part of the video if you're missing enough of your observations. So let's get things rolling here. About 2 centimeters wide seems to be a decent width. So we'll be using that for each of our strips of absorbent paper. And we want to use an absorbent paper because we want this capillary action to happen. You'll notice the same thing will happen with paper towels. If you roll up one sheet of paper towel and kind of just let the one end of it hang in a liquid, that liquid will start to travel all the way through the paper towel. This is an important process for flora, for vegetation as well. This capillary action doesn't just happen with water. We're not using water, we're using our isopropyl alcohol. All right, so I need to, now that I have my 2 strips of paper, I have my mixtures here, my inks, and I need to unbend my paper clips, and then we'll fit our filter paper, we'll cut it down to size to fit properly in our beaker. So let's get a couple of these unfolded. There we go. And then I'm just going to poke it through, not the very top, because we don't want it to break, something like that. And we'll trim off the bottom. You can either trim off the top or trim off the bottom. I'm going to trim off the bottom. There we go. All right, when I place it in my beaker, we can see that I have some extra, it's all bendy. We don't want that going on. So we want to take off a little bit of our filter paper. So let's just take off about 1 centimeter or so. See what we're looking at here. All right, put it back in. And that looks like we're just about touching the bottom. So that one looks all right. Our other one, down here. Let's go. Okay, so that one needs a little bit trimmed off as well. We'll go with, let's say, about 1.5 centimeters of that one. We just want the very bottom to be touching the bottom of our beaker. Okay, so that's how both of our strips are going to go in. We'll have, once we get our mixture on there, the camera will be watching these guys and we'll see what happens, recording observations every few minutes. Depends on how quickly this all happens. So now we just need to put our ink on each of these guys. Our inks are our mixtures. So I'll start with my black Sharpie here on this one. I don't want to put it at the very bottom because I want to give it some space so we can clearly see the capillary action starting to happen. And I'm putting a dot at the top to make sure I know which one is which, because who knows what these colors at the bottom could change to once we get that solvent moving through it. And now we'll do our red one on the other one. Careful not to make a hole in our filter paper. Okay, and put our red dot at the top. There, so we are good to go with those. Okay, at this point we're going to put in our isopropyl alcohol in the bottom of our beaker, just enough so that the bottom of our coffee filter paper or absorbent material will touch. And once we get them both in there, of course, adjust our camera angle so we can see them a little better. We're also going to start our stopwatch. Okay, so we have our black marker or black ink mixture on right side, left side the red ink mixture. You already see the capillary action happening where our isopropyl alcohol, the solvent, is climbing up our coffee filter paper, approaching the places where we've drawn in our red and black ink respectively. So now is an okay time. Like I could do an observation right now and record the time as about 50 seconds right there. We could record the time and say, okay, at this point we would say that our isopropyl alcohol is proceeding up the filter paper, but it has not yet made contact or done anything to the ink. The ink remains the same, looks the same. And you can add a little sketch to that showing that, you know, we get this portion of the filter paper is still the original white, and you have a slightly different coloration down there at the bottom where the isopropyl alcohol has already wetted the paper. As it continues to climb up, you can see it's encountering the red dot first, just because it's lower on the paper. But we should, anytime we start to see any differences, we can record a new time. Which you're probably just going to have to end up putting that as a digital timer on the screen. And then with that new time stamp for your next observation, you can draw a little sketch. What does it look like now? Make sure the time's on there. And then also provide a couple of phrases. Describe with words what you see happening. the next time you write an observation. We want at least 5 of those as we're going along. So I would wait until we see, maybe until that isopropyl alcohol passes through our first blob of ink, the red one. Maybe we'll see something different. We could do an observation then. But we'll just continue to let the clock run so we know what timestamps to put down for our observations. Make sure you're including a time, a little sketch, and a few words of your own words describing what you're observing. And this could be done on a separate sheet of paper. If you wanted to insert the photo into the lab guide, that'd be fine. Or you can do you can do it right there in Cami and do a little sketch using some of the drawing tools. That's fine as well. Remember that you can use the arrow keys, left and right arrows. By default in YouTube will go forward or back 5 seconds. So I'll probably just let this play in real time, and you can skip ahead, go back, record timestamps of when you see something happening. And you can also use the number keys, 1, 2, 3, 4, 5, etc., to jump to specific points in the video. Like 2 would get you to 20% of the way through the video. It's another way to jump back and forth. So at this point, notice that our isopropyl alcohol is just now barely reaching the bottom of the black ink. The red ink gets it's moved mostly through it, and it seems to start to be changing the shape of that original blob that we drew. The outer edges look a little lighter, as if it's being spread out a bit. But other than that, nothing dramatic. Alright, it's been a while. I'm going to carefully lift this up so we can see a little more close up what's going on with, especially the black ink. I don't want to tilt it too much. The black ink, there's actually some color in there. It looks kind of reddish orange near the bottom, a little kind of greenish in the middle right now. The shape, we could say, of our red one has changed and it looks lighter colored at the bottom. But some weird's going on with the black dot. Definitely like there might be some colors being separated or something. I'm going to put in a little more isopropyl alcohol to make sure we got enough going on in there. Don't want to splatter it all over. It's a little more difficult to see in the camera. We'll turn them around. You see what's happening to that black dot now? Now the isopropyl alcohol is almost all the way through our black dot. It's bent a little bit there in the camera. But turquoise-ish colored now at the top. The bottom more purplish or maybe red. Doesn't seem like there's much happening with our orange one or our red ink, though parts of it do look more pinkish now. That might be a good observation, especially for the black ink. Seems to be composed of something more. Just the black ink. Let's see if we can prop this up, maybe make it easier to see. What the heck? Just gonna adjust our height here. So it's a little easier to see. Well, our solvent is certainly taking a long time to move its way up the filter paper, but it is moving. It's a lot easier to see differences right up here close in person than it is with the camera, I think, but we'll try to see if we can get a more close-up picture of our black spot. If you can focus, camera. Let's see. You see there are definitely different colors there. The greenish turquoise-ish color is just at the top. We have a different shape of this black dot now. I see pink and a little bit of orange and red and the black ink now as well. See if you can see that. Much more interesting than what's going on with our red dot here. It has changed shape differently. That may be partly to do with the type of substances that make up that mixture. So for some reason, our red ink seems to change shape more dramatically, you could say, than the black ink. Because it's gotten much longer, and you can even see down there, it stretches all the way down to the bottom almost. Whereas the black ink is not spreading out as much, but we see a lot of other colors coming out of the black ink, which is an interesting difference. So we can move our camera. Let's keep sliding around. So we're coming up on the 33 minutes and 30 seconds right now. Haven't seen too much more in the way of changes. The red ink seems to kind of be disappearing at the bottom. It's becoming clear, whereas the black ink is holding itself together like it's bound together. The parts that make up that mixture maybe they're more strongly bonded together. So it's harder for the isopropyl alcohol to separate the pieces. However, you can definitely see these different colors in the black ink, as if it's made up of more things and different things compared to our red blob on this side, which it's hard to tell that it's even made up of anything other than just red, actually. And it looks like it's kind of being loosened up and pulled apart very easily, because its shape has changed more dramatically. You might say there's some orange or pink. It looks more pinkish in the not in the camera. Just looking right here, it looks more pinkish at the bottom of the red, and eventually goes clear. But it might look a little orange to you. According to our observations that you see from the camera view. And we'll probably just leave it another 10 minutes to see if there's any additional changes to the shape or other colors we might see. There's really quite a bit in the black one at this point. Might not have been expecting that. Okay, we're going to bring our observations to a close. We can see big differences in the shape change that can be discussed in our observations. The amount of ink that seems to be left over is different for both of them. The colors present from the black ink that's undergone this chromatography, those colors are definitely different than what we see from just the pure red ink on one side. So make sure you fill out have at least 5 different observations. You can go back through the video and look at different parts to make sure you have at least 5. Those observations should have timestamps. You should have a sentence or a couple phrases written about each one describing written words, what you see, as well as a little sketch of some sort. And you can do that on a separate sheet of paper and attach it or insert the photos into the lab guide, or you can use the sketching and drawing tools in Cami or another program to do that digitally. That's up to you. And make sure you answer the reflection questions at the end of the lab guide. As well as completing the conclusion.